Hello friends, I am George McCona and welcome to JJ's classroom. Today we are going to discuss about solvent extraction. So first one, that is the definition of solvent extraction. It is solvent extraction means that is a process of separation. The process of separation of organic substance from aqueous solution. So that is the definition of a solvent extraction, the process of separation of organic substance from aqueous solution. Here your organic substance is dissolved in aqueous solution. This aqueous solution is then mixed with immiscible organic solvent. So friends, that is most important. Okay, that is also the principle of solvent extraction. The organic substance which dissolved in an aqueous solution is then mixed with immiscible organic solvents. Now, what is immiscible? Immiscible means it's like oil plus water. You know, oil is insoluble with water. When you mix oil and water in a beaker, what happened? You got two different layers. Okay, oil upper layer, water is in lower layer. Both are not mixed with each other. That is called immiscible in nature. Similarly, water is remain immiscible with many of the organic solvent. For example, like ether, like chloroform, or we can say that kerosene. Okay, in your practicals, you are going to do practicals of kerosene with water. So that is called immiscible with each other. Here, in many of the cases, always the separation is favor the organic solvent. So that is the definition of a solvent extraction. Once again, the process of separation of organic substance from aqueous solution which is mixed with immiscible organic solvent is known as a solvent extraction. Okay, the principle work behind this is known as the law of distribution, or it is also known as Nernst distribution law. So our second point of discussion is the Nernst distribution law. It is also known as only distribution law. So what is the statement of a Nernst distribution law? Okay, to remember the statement, first of all, mathematically it is written as like this: D is equal to C1 by C2, or it is also S1 by S2. So look at here, that is the mathematical expression of Nernst distribution law. Okay, we move reverse. That means from mathematical expression to the statement. So here C stand for concentration. C stand for concentration of solute. Okay, concentration of solute in one phase, concentration of a solute in a second phase. Okay, that is S stand for solubility of a solute in one phase to the solubility of a solute in a second phase. And according to the definition of a solvent extraction, one is aqueous phase, another is organic phase. So that is called the ratio. That is a ratio. So that is called the ratio of concentration of a solute in organic phase to the aqueous phase remain constant at constant temperature. That is the statement of Nernst distribution. So you can easily now remember the statement with the help of this mathematical expression. Okay. So once again, the ratio of concentration of a solute in organic phase to the aqueous phase remain constant at constant temperature. This ratio is known as Nernst distribution law. Okay, but in exams, when the question is asked in 2 marks, what is the Nernst distribution law, or what will be the statement of Nernst distribution law, you have to mention some conditions. So I give you conditions on the board. It's like this: when a solute distribute itself between two immiscible phases which are in contact and in equilibrium with each other, the ratio of concentration of solute remain constant at constant temperature, which provide molecular state remain same in both the phases. So friends, that is the whole statement, okay, of the law of distribution. Those are called some conditions, okay, because your distribution law is here. Look at here, the ratio of concentration of solute remain constant at constant temperature. That is here, the ratio of the concentration of solute in two phases like organic and aqueous remain constant at constant temperature. Okay, so that is your main statement. But what are the conditions to fulfill the law of distribution? Condition number 1, that is the solute distribute itself. Look at here, that is the condition number 1. The solute must distribute itself between two immiscible phases. Okay, and these two immiscible phases which are in contact and in equilibrium with each other. What does it mean? Okay, the meaning of that is when you take organic solvent in one beaker and aqueous solution in another beaker, and you put those beakers on a table, and you assume that now the solute is transferred from aqueous to organic phase, then that is not happen. The condition is you must mix both the phases with each other. Look at here, which are in contact. Okay, so that is the statement. One more point is there, that which provide molecular state remain same in both the phases. Now what does it mean? That means when you mix aqueous solution which contain your solute with the organic solvent and you mix them or you shake them, okay, what happen? The solute which dissolve in an aqueous solution is separated with the help of organic phase. It's like this. Here organic phase, aqueous phase, your solute is moved from aqueous phase to organic solvent. In that case, the solute must remain in a same state. That means there was no any chemical reaction is take place when your solute is moved from aqueous phase to organic phase. The statement means that whenever it provides the molecular state, it remains same in both the phases. That means your solute does not undergo any chemical reaction, for example like association of the solute or dissociation of the solute. You know what is association and dissociation. Association means solute are combined together and form a new complex. Dissociation means it is a reverse of association, break down the compound and give 2 or 3 or more kind of many solute. Okay, so those are also known as the limitation of the law of distribution. The two phases must be in contact with each other, they are in equilibrium with each other. Also, the molecular state must remain same in both the phases. So, the question, the weightage of the question is 2 marks, and I told you that the question is like give the statement of Nernst distribution law and give its mathematical expression, that is in 2 marks. Okay, this mathematical expression is also useful as a MCQ purpose. Okay, so that is a 2 marks short question, Nernst distribution law. Once again, the statement is when a solute distributes itself between 2 immiscible phases which are in contact and in equilibrium with each other. Okay, then move here. The ratio of concentration of a solute in organic phase to aqueous phase, or you can say that between 2 phases remain constant at constant temperature. Okay, which provides the molecular state remains same in both the phases. So that is called Nernst distribution law in 2 marks. Okay, when I extend this question in a long question like 5 marks, I ask you like what are the limitation of the Nernst distribution. The next point is limitations of distribution law. Okay, so the full question is like this: give the statement of Nernst distribution law and also write down its limitation. Total 5 or 6 limitations are there. Okay, some are already present in the statement of the Nernst distribution law. We start point number 1, and we can say that limitation number 1, that is both solvent. Number 1, that is both solvent must be immiscible. Both solvents must be immiscible. That is the limitation number 1. Both solvent must be immiscible. Okay. The law of distribution. To study the law of distribution or the practical of solvent extraction, we use a glassware that is known as a separating funnel. That is the diagram of a separating funnel. You use this glassware in your solvent extraction practical. Okay, that is called separating funnel, in which 2 solvents are mixed together. One is aqueous solution, another is organic solvent, aqueous and organic solvent. Okay, it's like this. Where 2 solvents mixed together, those are immiscible. Both solvents must be immiscible in nature. That means they create a layer, they are not mixed with each other, and because of that reason there was 2 layers in a separating funnel. Like this, 2 layers are formed in separating funnel. Okay, this separating funnel then mix well for 15 minutes or 13 minutes for better separation. When you shake the funnel, what happens? These 2 solvents are mixed together. Okay, keep in mind they are immiscible in nature, but when you shake the funnel, when you shake the funnel for 30 minutes, what happens? These 2 solvents are mixed together. Okay, then you allow to stand the separating funnel in a stand. Okay, keep it for equilibrium. Then these 2 layers are separated out from each other. Okay, and at that stage your solute is separated, or we can say that extracted from aqueous phase to the organic phase. Okay, so both solvents must be immiscible in nature. One more point is there, or one more question is there. Here aqueous layer is at bottom. Okay, and the organic solvent is at top. So the question is, What is the reason behind it? The organic solvent is present at the bottom and the aqueous solvent can present at the top. That is possible. The reverse of that is possible. Yes, it is possible. So what is the basic principle behind that? It is a very common sense here. That is depends on the density. You know, much denser solvent remain at bottom, lower density solvent remain at the top of the layer. So here in majority of your cases always aqueous means water has a higher density compared to organic solvent like ether has always lower density than water. That means whenever you mix water and ether, okay, both are colorless in nature, okay, so how you can identify which layer is a water layer and which is a ether layer? So whenever you mix water and ether, water has a higher density compared to ether, and because of that reason ether always remain at top of the aqueous layer, okay. But in case of CS2, that is carbon disulfide density is 1.29 gram per ml, and you know water has a density 1.0. So now what happens here? When you mix water with carbon disulfide, obviously because of higher density, the organic layer, the CS2, is at the bottom of the separating funnel, while water is at the top of the separating funnel. So that is the basic funda behind identifying the layer of a solvent in a separating funnel. Okay, you must know the density of solvent which is mixed with water. If you know the density of a solvent, then you can easily identify which layer remains top of the separating funnel or at the bottom of the separating funnel. Okay, but in your chemistry practical, when you mix kerosene with water, it's easy because we use kerosene. It's like a sky blue in color, so you can easily identify which layer is of kerosene and which of is the water. Okay, so that is the basic identification in separating funnel, which layer is present at bottom and top. Now we move to our discussion, that is the limitations. Number one, that is both solvent must be immiscible. Already we discussed it in the law of distribution statement. Both must be immiscible in nature. Then second point, that is the temperature. Okay, the ratio must remain constant at constant temperature. So limitation number two, that temperature must remain constant. That is the second limitation. Temperature must remain constant. Okay, if you change the temperature, what happens? Why temperature is affected on the law of distribution? You know, okay, when you dissolve a substance in a solvent and you give heat or you provide the temperature, what happens? The solubility is increased. Okay, the solubility of that organic substance in particular solvent is increased. You done the practical in laboratory, like formation of a saturated solution. Okay, in case of formation of super saturated solution. Okay, how you prepare super saturated solution? Just heat the solution and add the substance. So what happens? Because of that temperature, more compound is dissolved in the aqueous solution or any solvent. Okay, so that is when you increase the temperature, the solubility is increased. When you decrease the temperature, cooling down the solvent, the solubility is decreased. That means temperature is directly proportional to solubility, and in the law of distribution, one ratio is there, that is S1 to S2, and I told you that S is stand for solubility. Okay, S is stand for solubility. That means temperature is directly affected or directly related to the solubility. That's why temperature must remain constant when you do the practical of solvent extraction. Then the next limitation, that is the law of limitation is applicable to dilute solutions only. Okay, only the law of distribution is only applicable to dilute solution. That means in case of a highly concentrated solution, the ratio, that is C1 by C2. Dilute solution means the ratio K is equal to C1 by C2. That is applicable. But in case of a concentrated or highly concentrated solution, this law is not applicable. What is the reason behind that? Because whenever the solution is highly concentrated means what? Your solute is surrounded by solvent particles. Okay, dilute solution, the number of solvent particles around the solute are very less. Concentrated solution means what? Your solute particle is surrounded by number of particles. Okay, it's like this by diagram. Okay, that is your solute particle. That is called dilute. That is complicated here. In a dilute solution, your solute, okay, your solute is surrounded by few particles of a solvent, while in a concentrated solution, your solute is surrounded by number of solvent particles. Because of that reason, when you mix them with organic solvent, what happens? The process of separation, the process of extraction of that solute from dilute solution is easy because of less number of solvent particles, aqueous particles. While here in a concentrated particle, it is hindered or resisted by the particles, number of particles present around the solute. So because of that reason, because of number of particles, solvent molecules around the solute, you cannot easily separate out or extract the solute from aqueous solution. Because of that reason, the law is only applicable to dilute solutions. Okay, then the next point or the next limitation is depends on if it undergo. Limitation number 4, that is called if association of a solute take place when it moves from aqueous solvent to organic solvent, then what happens? If association or dissociation take place, the law of distribution is modified, and it's like this. In case of association, this ratio K becomes C1 by root of C2. Okay, and in case of dissociation, the ratio is modified like C1 by C2 1 plus X. Here X is degree of dissociation. Now these 2 points, these 3 points are used in MCQs. Okay, so for dilute solution, the law of distribution K is equal to C1 by C2. If association of a solute, keep in mind, if association of solute from aqueous phase to organic phase is happen, when your solute move from or separated from aqueous phase to organic phase, aqueous to organic. Okay, so association and dissociation take place in which layer? Association and dissociation take place in organic layer. Okay, in that case, the ratio is like this: C1 by root of C2. That is called association. The law of distribution is modified when association is take place. Similarly, if dissociation is take place, I already explained what is association and dissociation earlier in our discussion. So when dissociation take place, the ratio is modified as C1 by C2 1 plus X. Okay, here X is known as the degree of dissociation. So these are the 5 limitations. Limitation number 6, that is mutual miscibility does not alter when it moves from one to another phase. Okay, one to another phases. So that is the limitation number 6. Okay, it's like the mutual miscibility does not alter. Alter means change. Does not change when solute moves from one phase to another phase. Now, what does it mean? What the statement means here? Okay, here two solvent, two solvents are dilute in nature. Okay, two solvents are immiscible in nature, or we can say that they are sparingly soluble in nature. When your solute move from aqueous to organic phase or from one phase to another phase, the miscibility. Okay, miscibility. This word is in corresponding to the solvents. When your solute move from aqueous layer to organic layer, the two solvents which are immiscible in nature remain immiscible. Okay, after the movement of the solute from one phase to another phase, two solvents not miscible with each other. The statement means mutual miscibility does not alter. Miscibility remains same. The two solvents must remain immiscible after movement of a solute from one phase to another phase. When your solute move from one phase to another phase, and if the solvent becomes miscible in nature, if they mix together, then the practical is wrong. You cannot separate the organic phase from aqueous phase. That is the reason behind it. Whenever your organic solute move from one phase to another phase, your two solvent must remain immiscible in nature. So those are the limitations of the law of distribution. Okay, both solvent must be immiscible. Temperature remain constant, or temperature must remain constant. It is only applicable to dilute solutions where the ratio is C1 by C2. If association take place, then the ratio is modified like C1 by root of C2. If dissociation take place, then the ratio is modified like C1 by C2 1 plus X, where X is a degree of dissociation. And the last limitation is called the mutual miscibility does not alter when the solute, it means when solute moves from one phase to another phase. So that is your question number 1. Okay, give the statement of law of distribution, give its mathematical expression, and also what are the limitation of the law of distribution. Okay, in 2 mark short question or in MCQ purpose or like a long question, that is very important for you. So that is all about today's lecture. If you have any doubt in your mind regarding to that question, you can ask me in chat box, or you can also message me via WhatsApp. Okay, I provide this video via a YouTube link. Okay, I create my YouTube channel that is called JJ's Classroom. Okay, so I provide you link of my YouTube channel. You subscribe the channel. Okay, I upload my video in that YouTube channel. You can anytime access the video, and if you have any doubt in that topic or in the video, then also you can comment your question in YouTube channel also. Okay, my channel is called JJ's JJ's Classroom. I upload this video in that channel also. Thank you for watching.